Section 4.3 RA-7. Suppose a doctor measures the height x and head circumference y of 8 children and obtains the data below. The correlation coefficient is 0.955 and the least squares regression line is y is equal to 0.236x plus 10.996. We want to complete parts A and B below. We want to compute the coefficient of determination r squared. Well, if we pulled up this data in StatCrunch, okay, we can then determine using the stat regression and then select simple linear. And so if we select the height to be x, the head circumference to be y, and then select compute, then we're going to see that the correlation coefficient that's given up here is 0.955. Okay. Now, if we want to compute the coefficient of determination, well then what do? We take that number, which is the correlation coefficient of 0.955, and then we square that number. So then we want to get the coefficient of determination. Squaring that gives us 0.9121371. We want to convert that into a percentage. So we move that decimal place over to the right 2 times, and therefore the coefficient of determination is 91.2%. Okay, now the next thing that we want to do is we want to interpret the coefficient of determination. Okay, so let's go ahead and do that. So what this means is that 91.2% of the variation in head circumference is explained by the least squares regression model. Now, if we take 100% and subtract 91.2%, then there's 8.8% that's left over, and we still need to take that into consideration. So therefore, 8.8% of the variation in distance is explained by other factors.